All right, guys, check this out. This says factoring quadratic trinomials, and if you read along with me, it says ax squared plus bx. That's standard form, but check it out. It says where a does not equal 1. Okay, so it's easy when you have a 1 right here. Because when you have a 1 right here, you simply think what times what is c, that if I combine together is b. But if you have a 2 right here, or a -3, or something else right here, everything gets messed up. It's really difficult to do. Well, not really that difficult, but there's more steps involved. Okay, so we definitely need to review this. Actually, I needed to review this. I kind of froze up yesterday. I forgot the exact steps on how to explain this to you. So I had to go back to these notes, and let's review them together right here. Step 1 is to multiply a times c. Okay, so let's actually go to this first one. Let me put a 1 right here. And what is a times c? Help me? There you go, -18. Okay, step 2. Think of the multiples of that answer, and I'm reading from up here on step 2. Think of the multiples of that answer that combine to give you b. Okay, so I need to think of the multiples of -18. Let me zoom in here. The multiples of -18. So step 2 is think of the multiples of -18. I'm talking about -1 times 18, -2 times 9, -3 times 6, -4, no, -5, no, I'm good. Those are all the possible multiples of -18 besides changing signs. So, I'm thinking of the multiples of -18 that I got from step 1 that combine together to give me the b value. And the b value is what? -7. So, if I combine -1 and 18, what does that give me? That gives me 17. So, that's not working. I need a -7. How about -2 and 9? That gives me +7, yes? But you want it to be -7. So what does that mean? You have the right numbers, you just have the wrong signs. So go ahead and change it to a plus and change it to a minus. And that's your correct combo. So that was step 2. Let's go back to the steps and continue reading step 3 here. Step 3 says, use that pair of numbers. Now this is a big one right here, the important one. Use that pair of numbers to rewrite the value of b, to rewrite the value of b as 2 terms, giving you a total of a 4-term polynomial. Okay, so like I said, this is a little complicated. You got to read that carefully. You want to take that pair of numbers. Let me zoom in again. You want to take that pair of numbers, the +2 and the -9, and you want to rewrite -7 as those pair of numbers. What do I mean by that? As +2 and -9. Now remember, this is a -7x. So when I rewrite this whole thing, let me start right here. 6x squared. Now here comes the fun part, rewriting -7x. And I'm going to rewrite -7x as a plus 2x and a minus 9x. Because plus 2x minus 9x gives us that middle value, -7x. Does that make sense? Now we still have the -3 that's coming down. Okay? Now, what I've done so far with steps 1, 2, and this was step 3, by the way. With steps 1, 2, and 3, the only thing I've done is changed a trinomial to look like a polynomial. I had 3 terms, now I have 4 terms. Now, most of us would say, why the heck would you want to do that? It looks uglier now. It's bigger. It's not as nice as the original one. But now, you could take this 4-term polynomial and you could factor it by grouping. So let's make a first group. Let me set some space. 6x squared plus 2x and then space -9x minus 3. Let's look at the first group. What could I pull out of the first group? What's in common here and here? Is there x's in both of them? Yes, there's x's in both. Okay, so let me put parentheses here. Let me put an x right here on the outside. But there's something else besides an x that's in common in this 6 and this 2. There's a multiple of what? 2. That's right. So let's pull out that multiple of 2 also. So the GCF here is 2x. Are you with me? The GCF is 2x. Now what would be left on the inside? 2x times what will get us back to the 6x squared? 3x, okay. And then how about a 2x times what will take us back to a 2x? Oh, it's already there. Plus 1. Okay, now let's look at the other one. What could I factor out of the other one? What's in common here and here? Is there any x's in both of them? No. What could I pull out of both of them? A 3, right? Now, check this out. Don't copy this down, just watch me. If I pull out a 3, what would be left? There'd be a negative 3x and a plus 1, and that's not what we have over, actually, a negative 3x and a negative 1, and that's not what we have over here. You see how they're different? So I would like them to look the same, so I'm going to go back and erase this, and instead of pulling out a 3, what should I really pull out? A negative 3. That would be so much better, because if I pull out a negative 3, then I really will have that same exact positive 3x plus 1, that same exact binomial positive 3x plus 1. And now I could take a step back and factor out that positive 3x plus 1. Let me put it right here, 3x plus 1. And what would be left in the exaggerated parentheses? What's left? 2x, that's right, and a minus 3. So there's your answer, 3x plus 1, 2x minus 3. All right, let's try another. So trying this middle one right here. What is step 1, guys? A times C. What do I get? All right, nobody knows. Negative 36, thank you. Okay, so step 2 is to think of the multiples of negative 36. Go ahead and make a list, right? So what numbers would work? You have negative 1 times 36, negative 2 times 18, negative 3 times 12, negative 4 times 9, negative 6 times 6. So those are all the possible multiples that give us negative 36. Now, step 3 is to think of those pair of numbers that combine together to give you the b value. So you could rewrite it as your new b value, but as 2 terms. Okay, maybe I said too much there. Let's just take one step at a time. Which pair of numbers combine together to give you 5? The negative 4 and the 9, right? If you combine those together, it does give you positive 5, which is your b value. So that was step 2. Let's move on to step 3. Step 3 is to rewrite your b value, which is 5. Actually it's 5x. Rewrite your b value, 5x, as these 2 numbers, negative 4x plus 9x. And you're going to end up creating a 4-term expression. So you have 12x squared minus 4x, I might as well leave some space, plus 9x, and then a minus 3 at the very end. Now, why did I leave this space right here? Because I already know that the next step is to factor by grouping. So in the first group, what could I pull out? What's in common in the first group right here? There's definitely a 4 and an x, right? So we're going to pull out a 4. That looks like a field goal instead of a 4. 4x. What's going to be left on the inside? 3x minus 1. Okay? Now, what could he pull out of the second group over here? What's in common? A what? A 3. And that would be a positive or negative 3? Positive 3. So let's put plus 3 that we pull out. And what's left on the inside? 3x minus 1. Okay? Now, what could I pull out of the whole thing? 3x minus 1. So I'm not going to do the exaggerated parentheses anymore. I'm assuming that after the first couple of examples, we're getting all this. So I pull out the 3x minus 1. What's going to be left? A 4x plus 3. And that's my final answer. So we've been factoring, but this section's not really about factoring. It's about solving using factoring methods. So let's go to flip the page. Zero product property. We already talked about this. The zero product property simply states if you have something times something that equals 0, then that first something could be equal to 0, or the second something could also be equal to 0. So in a sense, zero product property lets us separate them. So listen up, guys. on this original quadratic trinomial equation, right here, it really is an equals 0. If I ask you to solve, you need to find the numbers, the values of x that'll make it a true statement. So if you factor it, now this doesn't require factoring by grouping, but if you just factor it, what times what is negative 12, that if you add together is positive 4, oh, that's a positive 6 and a negative 2. Now it's in factored form. Now you have something times something equals 0, which means that the first something could be equal to 0, and the second something could be equal to 0. So now you have two simple equations that you could solve, and if you add 2 here, and add 2 over here, and over here if you minus 6 and minus 6, you're going to get those two answers, x equals 2 and x equals negative 6. So that's how we use the zero product property. We're able to separate them and come up with two simple equations. Now, here's the most challenging part probably of this entire section, where they ask you to solve a quadratic trinomial equation where your a value is not 1, right? The above example, the a value was 1, that was cake. All you do is think what times what is c, that if you add together is b. But in this case, you have the a value of 1, so you actually have to solve this thing by using factoring by grouping, okay? And remember those steps. You're going to have to do step 1, multiply a times c, and that's negative 6. Yes? Or no? Yes. Step 2, think of the multiples of negative 6 that combine together to give you the middle value b. So let me make a list. Negative 1 times 6 or negative 2 times 3. Which pair of numbers combines together to give you a positive 5, which is your b value? Which pair of numbers? Negative 1 times 6? That's right. So we're going to take that pair of numbers, and step 3 is to rewrite your equation. Let me do step 3 up here. Rewrite your equation, but instead of your middle value b being 5x, positive 5x, let's rewrite it as negative 1x plus 6. So let me rewrite the whole thing. You have 2x squared, and instead of plus 5x, I'm going to have a negative 1x plus 6x. And then at the very end, we have that minus 3, and of course it's equal to 0. Everybody with me? Okay, so now let's do factoring by grouping. I just created some space there. Now what's in common in the first group? What could I pull out of the first group? What could I pull out of the first group? X. If I pull out that x, I am going to have a 2x minus 1 left over. And in the second group, what could I pull out? Positive 3. And if I pull out a positive 3, what's going to be left in the parenthesis? 2x minus 1 also. Now you take a step back and you factor out what's in common in both the first group and the second group, which happens to be the 2x minus 1. So if you pull out that 2x minus 1, what's going to be left on the inside? There's going to be an x and a plus 3. Let me move that up. Okay, so now what we really have is a 2x minus 1 times x plus 3. And of course that's equal to 0. So now because of zero product property, I could split them each and set them each equal to 0 and solve. So they're each equal to 0. Now I'm just going to solve it. Plus 1, plus 1. I'm going to get 2x equals 1, which means that my final answer on this one is going to be x equals 1/2. X equals 1/2. Now the other one, just subtract 3, x equals negative 3. Ladies and gentlemen, those are your two answers to the above quadratic trinomial equation right here. I hope this makes sense. I hope it helps. I'm done.